Artificial minds in virtual spaces. This is a panel on artificial intelligence and the intersection with immersive media. So we're going to cover a wide range of things, but the center of it is going to be artificial intelligence and how that's changing our world and how that will shape virtual environments. My name is August Bradley. I'm the producer and host of Mind and Machine, Discussion on the Future, a talk show where we interview people at the forefront of transformational technologies. It's a podcast and a YouTube channel at mindandmachine.io. And through this process of finding the most fascinating thinkers and doers in emerging medias, I've come across this extraordinary group of people. And these guys are all doing fascinating things in some capacity in artificial intelligence, and in many cases overlapping with other emerging media, or other emerging technologies. So we're going to dive deep across the board. So let me introduce our panel. First off, Stephen Scully. Stephen is a computer scientist. He is the founder and CEO of the Vane Company. Stephen, why don't you tell us a little bit about what you guys are focused on?
The Vane Company, we're a group. We do special projects with emerging technologies, and basically we're always at the forefront of using advanced technologies to execute projects for companies that are trying to solve business problems in new ways. And I guess we've used AI pretty extensively. Mainly the computer vision side of AI has come up with a lot of applications, basically a way of just like extracting information from reality. And over the past decade, I've seen huge transformations in terms of what you can do and what you can recognize about environments. My personal history with AI goes back to doing things with genetic algorithms and FPGAs back in the day when people still used genetic algorithms for things. So yeah, it's great to be here. Yeah.
And we have Ramsey Braun, a neuroscientist and the chief operating officer of Boundless Mind.
Thanks for having me, August. So I'm Ramsey. I'm the co-founder and head of operations at Boundless Mind, and we use artificial intelligence to help apps become more persuasive. So by helping apps optimize how they use positive reinforcement to deliver small bursts of dopamine inside their user experience, whether that's through a smartphone app, a web app, a virtual reality application, IoT, or a chat-based client. When and how an app delights people is going to determine how their brain forms new habits, and we personalize that to each person individually. So I've had the pleasure of training as a neuroscientist, as August mentioned, and now turned developer and mostly business evangelist. So I get to come and do fun things like this with fun people like this. And it's a pleasure to be here, so thanks for having me, dude.
And Kelsey Scharnhorst is a researcher at UCLA focused on neuromorphic computing, which we're going to get in deeper later, but you can do a brief introduction now.
Absolutely. It's great to be here. So I make AI hardware microchips that are modeled after the human brain, and so they're very bio-inspired, and we look to use them to solve multisensory complex problems or hard-to-predict problems.
Fantastic. And Bu Wong is the head of emerging technologies at The Mill, a leading VFX and all things digital magic house.
For about 27 years, The Mill's been involved in making film and now going from making film effects for Gladiator to making commercial VFX, and then now we're also working in the creative technology space. So I head up the team that looks after emerging technology, which is a moving target, as most of you know. Today it's VR. We do a lot of AR, and we also work in physical and virtual installations, and then also computer vision and AI. We've worked with IBM's Watson, the music team, on a project that basically visualizes, its analysis, Watson's analysis of semantics as well as music composition. And then we've also just recently, as part of a talk that we did at South by Southwest, created an AI that did a live duet on stage with a human beatboxer, which is super exciting for us to actually train two neural nets to listen and then know how to actually do a real duet with the human.
It's so fucking cool.
Fantastic.
It was really fun.
All right, so to set up a baseline on artificial intelligence, Stephen, maybe you can kick off and tell us what we mean by the term artificial intelligence, and maybe you can tie in machine learning and deep learning and how that all fits together.
Yeah, I mean, artificial intelligence can be a contentious term. Is a computer intelligent? And sort of my perspective, the computer science perspective in the 50s, people, made the first machine to play chess, and they started this guy Herb Simon, started this thing called the general problem solver. Can we make a machine like the human mind that can sort of solve any problem? This didn't work out so well. We still had these tasks like playing chess, certain advanced complex things. Could computers do it? In the 90s, we saw the first machine called Deep Blue beat the grandmaster Kasparov at chess. It was a landmark for AI. But despite that, people were like, oh, computers aren't intelligent yet. Right? A lot of the history of AI is continually moving the bar. Computers achieve something, and then we're like, oh, no, that's not quite where we're at. They're not intelligent yet. But actually what we saw with that Deep Blue example with chess was the techniques used by Deep Blue weren't actually much more sophisticated than the techniques from 10 or 20 years prior. It was just that they baked them into hardware. So Deep Blue, because everything was happening in computer hardware, could evaluate like 10,000 board positions per second, 100,000 board positions right before making a move. And so it's this curious history where we're like, what in computer makes them intelligent? What in us makes us intelligent? And what we've seen across time is it's a combination of these specific techniques of like how you structure the stuff in the computer and just raw horsepower. And that's kind of where we are today in artificial intelligence. You've heard about these deep neural nets. And basically what those are, they're systems that are inspired by neurons. And you have a bunch of different nodes linked, and they take in information, they make decisions, and send it down sort of to the next layer. And what we have now are these things. The first neural computers were also done in the 50s and 60s. They were very weak. And now we have so much horsepower that we can have multiple layers of classification happening in these systems. And these are the really successful AIs of today. And so you'll have a whole system just generated to like taking pixels in, right? And that system might turn the pixels into lines and edges and basic shapes. And you have another system that takes basic shapes and tries to group them together into an object. And you have another system that takes the objects and groups them together. And so we just have so much computation to throw at it that we have these great things, And a lot of the sort of boundaries of AI are about supervised learning versus unsupervised. So the systems that are really successful today, you show it certain stuff, and then it can either like detect stuff like that, it can make stuff like that, but you have to show them very small amounts of things. And people are like, can we get unstructured learning, where things sort of figure it out for themselves? And these days, there's a lot of exciting work. We're actually getting really close to that, where you just give a very low, like there are systems built with just you just give it like a positive or negative, right? Like dopamine or pain, right? And that's the only input you give it. And these systems are starting to learn. And we're actually finally, in this really roundabout way, achieving the goal of the early computer scientist, the general problem solver that can be sort of a general intelligence. So, I don't know.
As a neuroscientist, how does a dopamine hit drive behavior?
I'll answer that and have a sec. Stephen, per the historical definition of AI, there's always 3 quotes that jump at me that I feel like audiences often appreciate hearing. The first comes from John Kay, who's largely regarded as one of the modern parents of artificial intelligence back in the 50s. And he said that the initial goal of artificial intelligence was to just be able to mimic things that human minds do. So the early things like that were things like chess that were obviously academic and hard. And then it became easy for a machine to solve chess in the 90s. We just now have machines that can detect cats in YouTube videos. It should be a thing that should be quite easy. It is easier to detect a cat in a YouTube video than it was to play chess. But chess was able to fall first because we could break chess into a series of rules. It's hard to say what defines a cat. Is it detect ears and little whiskers? Is it has tail? Is it likes to sleep on my printer? So it turns out the things that were actually quite easy for humans to do turned out to be a son of a bitch to solve for computers. And things that were a son of a bitch for humans to do turned out to be quite easy for computers to do if you could break it into steps. So that was kind of the starting point for it. Then going forward, there's 2 quotes I always remember, is that to an approximation, if it was invented after you were born, it's technology. If it was invented before you were born, it's just the way the world works. So we talk about AI today, but we've been talking about AI for 60 freaking years. Like really quite a while that term's been around. And now our definition of what counts as AI just keeps moving, because it used to be back in the day that a machine that just kind of beat you at chess was deep AI. And now that's just that one app you have on your phone that you're praying to God you can eventually get good enough at chess to play your grandpa without the shame of the family. That used to be AI, now that's just an app. But now our definition of AI has kept moving, because if it's made after you're born, now it's advanced. The second thing I think about is that AI has always had this really deep history linked in with robotics, in which any machine that has been built since you were born can be considered a robot, and then everything else that was built before you were born is just a machine. So if you go back and you look at like Popular Science magazine in the 40s, it was talking about things like the automated home dishwashing robot. It's a washing machine. But it counted as a robot because it was a sufficiently advanced technology at the time. It was an intelligent thing that was doing a thing only humans could do at the time. And then as it turns out, we could keep breaking these human processes down into predictable, modelable steps, or systems that we could, using neuromorphic computing or approximations of neural computing, figure out how to decompose. They became just machines. They weren't robots anymore. It wasn't artificial intelligence anymore. So as Stephen pointed out, the interesting things today going on in AI are all these things that take in information and learn the way brains do about how to predict reality or how to model that. August, to your point then about how dopamine plays in for the neuroscience part of this, who here has been to Las Vegas? Yes, you're attending an interactive panel. Raise your hands. Who's been to Las Vegas? Okay. Now keep your hands up. Keep your hand up if you've ever played a slot machine. That's a lot of you. I'm not here to shame you, though. So what's going on with a slot machine? You have a behavior that you've been instructed to do, pull the lever. And sometimes, but not every time, there's going to be a payout on the machine. Does this kind of sound familiar? Okay, like I said, interactive panel.
Blinky lights that I like, though.
That's what gets you in. That's the cue that draws you in. But it turns out the unpredictability of the payout is what causes your brain to release the neurotransmitter dopamine. Dopamine's one job, aside from kind of colloquially being the sex, drugs, and rock and roll molecule, is that if you predict something's going to feel only so good, and it actually feels better than that, evolution has cobbled together this system to say, do that thing more often. Whether that's finding good food, good shelter, fresh water, a good mate, or opening up Instagram, playing more Candy Crush, going for a jog, sitting down at a slot machine, saying yes to August when he invites you to go on panels. Things that feel unexpectedly good, the brain uses dopamine to keep us doing that. The interesting thing for AI there then is if that's just another pattern to learn, that means now we're entering a state where human desires and motivations are a thing to be programmed like anything else. That's the interesting ethical question.
Awesome. As we think about immersive media now, connecting these AI and machine learning algorithms, one of the most immediate and obvious uses is autonomous digital characters in immersive media. Boo, how do you expect autonomous characters driven by AI to differ from programmed characters in immersive media experiences?
Well, I think, to your point, when you start to get the feedback back and forth, it becomes a totally different game. But before even that, like if you think about how do we interact right now with animated characters? It's all on a screen. It's pretty detached. You're watching it. Even if you play a game, it's still kind of like I made it click. Whatever. Maybe my response triggered some other, effect. But it's still pretty passive in a way, and it's very detached. But when you think about the mediums that we're talking about right now, just starting with VR. VR is not for everything, that sounds horrible to say in this thing, but it might not be for everything. But, when it is right, we all know when we've been in a good VR experience, it really affects you. It does have that memory thing that, people talk about, but then it actually is real. You remember where that table was when you were in the experience, or when an avatar actually looked at you, and you feel it. And I think that the line basically we're closer to the gate to the relationship with an animated or a digital avatar is closer now than it's ever been. That's just for VR. If you consider AR, where basically they're not even just like, oh, we're in a closed off space and this is the imagined space, might look like my living room maybe. But once they're in the real world with us, that gets you even closer to the relationship that you're going to have with digital, objects, characters, smart or not. Right now we're looking at things through our mobile devices mostly, but then when you think about having things, on HMDs, contact lenses, brain implants, we're not that far off from it. Not so long ago when, you first used, monocles and things, nobody ever would have said, yeah, and then now you're going to put like thin films of plastic in your eyes or beam lasers through to fix your vision. It would have been laughable. So, we have to take brain implants seriously, So I think that, from that point, and if you just talk about the platforms now, the immersive platforms where you're talking about VR and talking about AR, now you throw in AI, and suddenly you're in a whole different game. You're talking about something, it's a personification of something that is digital and of an AI. You know, when you think about AR and you look at your kids and they're playing around with AR, and when they start to think about what is real and what is not real. When they wake up in the morning and they want to find the unicorn that they left sleeping in the living room last night, that's where we left him before you all got tucked in bed, then you're just like, wait a minute, what is real and not real? Because they saw it on the mobile device, but soon in glasses or somewhere else, and they start to have a relationship with it. Then you may make it have a brain, and now it's personal. And it has a character. You put a face on code now, and the code is thinking, and it's responsive to you. The relationship is entirely different. It's a whole different game.
Is it conceivable we could have the kinds of relationships with autonomous AI-driven characters in virtual space that we have with humans, love, emotions like that?
I absolutely think so. Anybody who's ever, like, you know, played D&D and had some character die and you feel that, like, oh crap, you know, or if you actually have a character in a video game, and these aren't even the ones that are with you day to day, following you around, responding to you, you know, making, I'm sure we'll cover this later on, but like making the world around you exactly what you need it to be, and knows more about you than maybe anybody else does, because in a way, you might control, you know, obviously there's feedback back and forth. You're going to control a lot of how they learn, and at a certain point, the reverse might be true. And then you suddenly have this really symbiotic, you know, friendship or relationship.
And those AIs could know the history of your behavior in a way no other person ever could.
Yeah, depending on how much you let them follow you along every day, every second. It's really, you know, hopefully it's up to you.
I think that's the neatest part, because what you're introducing is that personalization.
Right.
There's only so much personalization code alone can do, but the second you start introducing systems designed to, in the same way that brains learn, adapt from your patterns, make predictions about how you might enjoy this scenario or this experience, now you're really building a machine that is going to be in feedback lockstep with your mind.
Okay, so hold on. But then once it has a personality, like any other friend, you're going to be like, where do you want to go?
And what does it want? That's the question.
Exactly.
It wants to take you back to the store for more in-app purchases.
Don't call it it. Anyway, yes.
He, she, they?
All of it. They, all my friends.
There it is.
So where are we now in that evolution? Because the experiences I've seen are compelling, but they don't really seem truly human.
Right.
In the best experiences, where are we now?
Well, I mean, you know, if companies like The Mill, like, we're all about that visual fidelity. If you look at the history of the work that we've been making, you know, for films, commercials, VFX, we've always been about pushing visual fidelity. It's not all about that. There are wonderful experiences, you know, that people really enjoy, I enjoy, that don't have to look real. There's very graphic things that are amazing. It's about the experience. It's about the gamification of the experience. And like, that is not to be discounted on the logic behind the system. However, once you get all of that in place, the visual look of things is also critically important, and that will help with the believability. Now, it isn't the only thing it hangs on. I think that there are other things that might be more important than just how things look. But all that being said, you know, companies like The Mill, and, you know, we do care, we don't neglect that side either. And coming from a long history of filmmaking where we know what looks good and what doesn't look good, I can tell you there's a lot of resources being put into how to make immersive content look as good as possible, because it helps the brain make the connection in some cases.
Kelsey, you're at the ground floor of building authentic behavior from machines. Is it conceivable to you that machines will be purely, will behave in a way that just seems 100% authentic in human interaction?
Well, I don't know exactly how authentic they're going to be, but I think it's definitely feasible that they could be. I think that the most important thing about having AI hardware paired with the AI software is that you can minimize that lag, which is very important in VR systems and causes people's motion sickness. So getting that lag down as much as possible while still having a huge amount of complexity to the system or the world that you're imagining or seeing, and the computer is imagining. And
you make a great point. Artificial intelligence processes a massive amount of data.
Exactly.
An exponential amount of data.
Yeah. So that's where I see it.
And we already have challenges
play.
at getting at 60 frames a second and with zero lag. So from a computer science standpoint, how do we get from here, where we are now, to these authentic, autonomous, human-like agents? Computer scientist?
Yeah, whatever. I think we're. I think we can't neglect the history of games and what they call in the gaming industry AI, right? They're AI characters in game worlds, and they run around and they have convincing interactions with humans, and sometimes they're as challenging. They can easily be more challenging than humans. The challenge in the game world is, your AI can always cheat and like see things that an authentic player couldn't see, right? And so you can create challenge in all different kinds of ways. You don't necessarily need to honor the rules. But there's been a ton of interesting work over the past 5 years. Some of this stuff is published in research papers. You can also check out this guy, Seth Bling. He has this YouTube channel where he trains AIs to play like Mario Brothers and stuff. And they actually have the same interface that humans do, and they learn to play games. And these systems could, make a World of Warcraft or a shooter, Battlefield kind of character that could play convincingly like a human. And in a way, that's exactly sort of what we've been talking about has been achieved in a certain light. I think when it comes to VR, what I find interesting about being in VR spaces is that unlike regular games, like if I play a game, I can't really differentiate the computer AI from Kelsey if she were to be playing, right? This still looks the same to me. When I go in VR, I can instantly tell the humanness of a character because of the way, everyone's seen the floppy hand and stuff. It's like AI characters in VR don't have all that physicality that humans have. So I think one of the things, the challenges the unique challenge of VR is to have that bodily sensibility that's convincing. Right now, what we have in game space is a very convincing planning, strategy opponent. He's really convincing, easily be better than humans.
Right, but it's sterile, is what you're saying. Like it always executes perfectly. It doesn't have that edgy humanity.
Seriously, they don't feel sterile. Like playing against a good computer AI in like a shooter game or something like that, it won't feel sterile to be like, wow, this is really badass.
They're good, but they don't have the floppy hands problem. They don't jerk like humans jerk.
Yeah, it's like VR has given us, exactly this new thing, to experience in digital spaces, humanness. So.
August, I thought a little more about your question too about the computer science problems we still need to solve. I think we need to differentiate. There's two sets of problems. There actually are pure computer science problems, and there's computer engineering problems. And we can't pretend that everything we do with computers just counts as computer science. On the computer science side, the way that brains make decisions is extremely different than the way computers make decisions in terms of executing instruction code against data and then branching with logic to come to some sort of execution conclusion. A lot of more work has to be done, and this is a lot of, Kelsey, what I think that your team is working on and leading the way on is how on earth do you get neurons to solve problems in a way that's representative of how the brain has evolved to solve these problems? Then how do you map those problems back onto interesting engineering problems? That is a legitimate capital C, capital S computer science problem. Someone's gonna need a dozen fucking PhDs figuring out how the heck you make neural wetware that's been specialized to AI and VR hardware solve those problems in the time frames you're describing, so as they map towards interesting engineering
Why would you want to use wetware for that?
Yeah, we don't use wetware.
I'm sorry?
I don't use wetware.
You do simulations of but it's neuromorphic, so it's wetware inspired. Yeah. Right, so, excuse me.
So it looks like the brain.
Right.
It looks like a bunch of neurons, and it's faster, and there's more of them.
Perfect. Then forgive me for the faux pas.
But it is encoding the system, understanding what you're going to take those outputs and reconstruct or like add together and have meaning to is definitely a challenge, like a huge challenge in our field.
And that's so much of it.
It's kind of interesting. I was thinking of other ways that you could use AI hardware in VR the other night, and essentially what we do is we have an input, like a sine wave or something, and you put it in, and then it changes, and there's all these different electrodes you can pull out signals that the sine wave now looks like 20 different sine waves that are slightly distorted and changed. And if you're trying to create like a world where you go into a room and there's 20 people, it could be that you encode these signals to look like different people, and that would be paired with AI software to like create like, oh, they're short, tall, fat, what, like, These
are the kind of things neurons are good at doing at that speed.
Yeah,
right.
Yeah, absolutely. So that would be like real-time processing that could be having like a very interesting interaction with whoever's playing, but just a thought.
No, it's a good thought because it goes into the second piece that I think is there's the computer science half of it, but there's the computer engineering half, and that's how the heck do we get up to speed? All of this becomes really interesting only when it doesn't hurt play. It doesn't actually break the rate of play.
Yeah, I think we need to differentiate the solved problems from the unsolved problems, because a lot of these things are sort of already solved by more simple mechanisms.
Sure.
And people in CS are always trying to do things that haven't been able to be done before.
Yeah.
And on the frontier of AI, I think most of these, like, if it's a well-defined problem, you can kind of build an intelligence around it, and it's kind of like computationally limited. The things that are on the fringes of the AI are like, it's sort of like it's almost like, how do we make something we can't control? Right? Because like the supervised learning systems are all like, oh yeah, we're going to show you this pattern, you're going to be able to detect it, you're going to be able to, we show you a bunch of paintings, you make paintings that look like that, awesome. How do we get some computer that makes the painting you've never expected to see?
Autonomy,
So autonomy, free will, things like this come up.
Angsty teenager bot.
Yeah, and I think for the specific thing I talked about is like locomotion AI. So we could train a system for that, right? We could train systems to make mistakes that humans make in games. Like there's a market reason that doesn't exist to make AIs that seem like humans. So part of it is, I think, when I say why haven't we seen these things in games, it's like the market doesn't care.
Actually, no, it's not true. Like in Dota 2, you can train in different layers of like easy or whatever is hard or hardcore, and you have different levels of AI.
But
and they're really smart about it, and they do behave very human in the way that they don't.
No, but those
see.
AIs don't make it to Grandmaster. Like the experience. Like I haven't played Dota, but I've played League of Legends and Heroes of the Storm pretty extensively, and those AIs cap out. It's like that expert level AI is basically boring.
Yeah, when you talk about the top
it's
end,
good and it's challenging, but it's challenging in a really predictable way. And it's not going to have that same kind of deep, interesting, curious surprise thing of playing like an actual Grandmaster level player. And I think the reason is market. I think the people who make Dota, HOTS, League of Legends, they don't have a market reason to train AIs that are surprising and good, because there's so many human players on the game, and you want to play against those human players, and the AI sort of serves a purpose within the game. But yeah, those AIs are relatively mundane and relatively predictable. And
so last year they actually had an AI, deep learning AI, do a live game against a human. Did not do so well the first time, did okay the second time. But it'd be interesting to track with, actually, just reminded me and all of us, we should look and see how that deep learning AI did.
They should learn from the humans too, right?
They do well in the research context. The market hasn't asked for it yet. That's my point.
Now, beyond AI characters and autonomous characters, there's the idea that's increasingly discussed of synthetic intelligence shaping the world, becoming the world builder, the writer, the author of the experience. How does that change the user experience, particularly in terms of how it can customize based on all the information it knows about you, crafting a story and an experience uniquely for each user?
Yeah, I think of Minecraft as a starting spot, because before we talk about intelligently, maybe on the lower scale, we have what you call a procedural world, right? Where it's like relatively simple mechanisms. But if you played Minecraft, all those worlds are procedurally generated, and they're stunning. And there are many, many games now that do that same thing to create an environment. And we found we don't even need fancy AI to make like endlessly fascinating space that you can explore. I could imagine we could get better, from where we are today, but it's pretty damn good. The last 10 years have been really surprising. I don't think anyone would have expected it,
Yeah, and I think that, we consider our own environments, our own social media environments, or our web browsing environments. They're so customized already. We're living in a very kind of AI-driven world already, whether or not we want to, recognize it or not. So I think that it is, to your point about demand, I think it is about demand. As soon as us as creators, we decide that actually having an AI involved in the content that we make for people, if that is an interesting thing, that's when it's going to start to happen. And there are real reasons for it. I think that people do want personalized content. You see that in social media. You do, for better or for worse, and I think that we all could use some moderation in some socio-economic, political arenas. But besides that, like on the entertainment side, we do like to have personalized content. So we all want to have our own playlist. We all want to have our own Twitch stream. I think that, it's there, and I think it's up to us, as people. But
does it further these perceived reality bubbles that we are experiencing now on Facebook in a purely immersive space? Does that take us even further into separate realities?
Entirely, and there's such a huge revenue play there. So if we go with the idea that if you look at the existing revenue and capital structures for these entertainment companies and social media companies that are increasingly investing in both artificial intelligence systems for personalization engines and in virtual reality. Stephen, back to yours. So if procedural generated code can generate a relatively interesting Minecraft world, if we're assuming that interesting is the maximization criteria as opposed to revenue generating per player, and instead
they're correlated.
To a first approximation, if there is a 10% gain in the amount of time I will spend in a Minecraft world, and it is either monetized with advertisements or I have to pay per shovel or pick I'm using, and AI is able to make that gain by finding really small things to tweak about that, and the AI is less expensive to operate than the revenue gained and the en masse calculation for all players, we are just going to naturally slip towards the case where we're increasingly going to live in completely personalized and constructed of individual of these scenarios just on the return on investment for the economics. That if it means procedural code gets Facebook $1 per day per me, but AI generated personalized world might get them $1.20 per day per player. You're going to see the natural economic shift here that the introduction of more and more AI personalization in VR spaces means we're all going to be living in our own very, very perfectly tailored, but maybe alien or boring to each other little worlds based on prediction engines about what our consumption rates are going to be or advertising consumption rates are going to be.
I mean, there's a lot. You said a lot there to unpack, but I mean,
lightly dystopic.
I think this idea. So, like, there's certain. I mean, Boo, you said something that made me think of recommendation engines and shopping, and I think
Horrifying.
I think
Yes.
there's. I'm trying to address that and address what you said. There's something about this convergence. Like, we could achieve these means without like a deep learning solution, right? So it's like we could take this recommendation engine technology, which finds stuff you like, and the procedural technology, the recommendation engine's 3 matrices. A procedural seed is a 64-digit number, right? And we could like pair the two together, and we could go even many steps beyond, which is very basic technology. To your point, Ramsey. You're like, yeah, you could have this absolutely custom universe that was perfect for you, but that's not what gamers want. Gamers and people want to be with other people, doing things with other people and being social. And what's exciting for me about virtual spaces and gaming, and VR is a huge part of this, is the convergence of multiple people in a space and the ability for humans to also make this space, right? These technologies are going to amplify our creative power as well. And so I see these future virtual worlds. Sure, there might be AI generating stuff, advanced procedural stuff, merging of different people's tastes and preferences over time, but there's a huge piece of people being able to make stuff faster, better, quicker, and grander, which is a huge part of VR in terms of 3D creation as a medium. So
I'm going to be the devil's asshole here, though, because I know we're at a VR thing, which is going to be largely gaming oriented. I'm not proposing this is my worldview or reflects my corporation's worldview, but for the love of God, outside of the indie community, when was the last time the gaming industry treated its players with respect? Or does social media treated humans with respect? I mean, these are the lines of capital and people who are building the environments we're in. You think they're going to care what the players are doing?
Oh, they care. I mean, they really listen to their players. Like, you see these times where players revolt, they complain about stuff. Like, they do care about their paying audience.
It doesn't appear how they behave, though, because
Okay, we're getting into business models.
This is gaming.
We're going to
end up at Gamergate if we keep talking
Let's
here,
not.
and we could
Let's-
go there.
let's-
But
let's not.
do we really want to go
Kelsey, do you
there?
have a thought there? Then I have a question for you. Did you have a thought on this?
I was just going to say, I think that the beauty of VR is that you can have all of these different types of space, like not just like standard like racing games or fighting games where obviously people aren't going to be super respectful, but like you can have a graffiti alley where people are like spray painting, but like they're not actually harming anything. They're not performing a crime. But so what's it?
Right. So we touched on it a little bit, but I want the audience to understand really what you're working on because it is so extraordinary and mind-blowing. So these analog brain-inspired neuromorphic chips, what are they and how do you sort of cultivate them? Because you don't just make them, you grow them.
Yeah. So as I said before, they're brain-inspired. So we start with a very ordered grid and we put them in a solution and they self-assemble into this highly interconnected, super dense network that we functionalize. And then we basically get a ton of connections that are turning on and off, but rather than turning on and off, like a 0 or a 1. They aren't like a light switch. They don't flip on and off. They kind of slowly turn on and slowly turn off. And in that way, you can have sort of strengthening of different pathways and connections kind of in the way that humans process information in your brain. So if you are continually repeating something, you're making that connection stronger, and then that is kind of what we call long-term memory. And we see that in these sort of switches, but we basically have 1 billion per square centimeter of these switches, and these are the microchips that I
Right, so these neuromorphic chips that enable what's called neuromorphic computing. What kind of problems does neuromorphic computing enable machines to address that traditional architectures are not as good at?
So, I mean, there's a lot of potential. They're not exactly being used quite yet, or at least not on a massive scale. Certainly some prototypes out there, but they are very low power. So the idea is that if you want to have an autonomous robot be processing multisensory information from the environment and even employing the machine learning algorithms to identify water bottles as full or empty. This one's trash. Okay, let's pick this one up. So this could be potentially done in real time in robots rather than what we do now with robots that are performing these sort of things that you send out the data to the cloud, you perform the computation, and then it pings it back, yes or no, pick this up, don't pick this up. So this is huge potential in this area, but we're not using it yet.
Yeah, and when you bring that into immersive spaces and VR, AR experiences, is it a matter of making the behavior of the machine more human-like, or is it, is it shaping the experience in a different way, or is it just shaping it faster and more authentically?
Certainly faster, but I don't know. Yeah, I mean, the speed is very important for a real experience, but
you were telling me before, it has ambiguity. It deals with unknowns in a way that traditional computers can't.
Right, so it has fault tolerance. So what Stephen even said earlier that, you could have maybe the AI having some more error in it, and we certainly have error in our system, and that's a lot of people don't like to talk about error in a computing system, but it turns out that humans have a ton of error in the way that we process information. So it's just...
Isn't that what makes human behavior surprising?
Exactly.
Because like a robot will do whatever you ask it to, but humans sometimes just don't. Mm-hmm. And like no one has wanted to build a computer that doesn't do what you ask it to do. Computers are like slaves, right? We want to do exactly what we ask them to do, exactly how we do it. And we've had the ability to make computers that don't always do what we ask. Just for some reason, it seems like people don't want that.
Oh, yeah, weird.
Having a car with an attitude.
Yeah.
Please go.
Although if you're trying to be authentic in immersive interaction.
Yeah, and I think the authentic, it really is this, just thinking about, all this talk about this, computer design space or human, like I feel like this whole conversation, we're missing art, and there's something about art. Well, art, it's just like, I spent some time if you look at my CV, I spent some time in the art world. And the curious thing about the art world is that people who buy art, they don't want to buy art from a collective. They always want to buy art from one person. And someone else could make the same art, but it's like, no, it's the one person who started that art that matters to the collector and the audience. When we look at art, we don't just look at artifacts, we see an ego behind it. We see a consciousness behind that art. And you look at all these computers and these like things from Google that make these awesome looking paintings. And to me, they succeed on the, oh wow, my eyes popped, like wow, that pops. It's like you have that money in a gallery feel, from like the pop, but you're missing that deeper layer of like actual meaning and substance, So I think, I don't know where this fits in the conversation, but there's this gulf between these awesome virtual artificial minds. At what point does it say, this is what it's like to be alive, and this is an expression of who I am and my whole existence that you can tap into through looking at my art? And I don't know where this fits in our conversation, but that's a big thing that I think human artistry is always going to matter. And right now we're seeing humans decide how machines, like the artistry of the Minecraft team is in the decisions they made with their procedural generator. But, the guy who, what's his name, Notch or whatever, the Minecraft guy, like he grew up in Sweden in the farms in the countryside, and the game is that feeling that he had of exploring the countryside as a child.
So it's like his little mark left in it.
Yeah, and it's like there's something really real and tender there. I think what we're seeing today is ways for humans to express that in bigger and bigger ways, but the system itself doesn't tell me what it's like to be alive.
We have seen AIs try to create art, and the results have not been particularly successful.
They're successful on the bling level, but not at the, that deep.
Where's the tortured code? How does a computer do heroin?
What are the most interesting, fascinating, like awe-inspiring examples of AI in media interaction that you guys have encountered? What's like the leading edge right now of experiences? Gaming is fair. I mean, media interaction, not necessarily.
This is a really good question. I'm going to think really.
Well, so that says something too. The fact that we don't see these right now.
I think it's all about that line of AI, right? It's like, are we seeing deep neural nets drive interaction? No. Do we see recommendation engines drive it? Yeah, it's like I'm finding great stuff I want to see. I'm getting things fed to me. And matches are being made between different players for games. Like, they're algorithms. If we ask the question, in which ways are algorithms fueling our entertainment? I have no shortage of amazing ways in which algorithms have. If we say AI or something that feels like AI or deep learning, it's less clear.
I think it's still kind of like the challenge-based thing, like the Go AI, or the AIs that are just like, like we look at using AIs to basically perform kind of generalized tools that we want to make more efficient. So we might use something to improve color grading or to take care of rotos, and we try to train, but that's not really kind of creative media kind of use of what you would call, for AI. It's not the artistic side. So it's I'm kind of curious, like how is that kind of branch? Is there a branching that's seen there where you want the kind of like the more creative thinking, inventive AI as opposed to the like just do this better, faster by yourself? And
there's the Parlor trick AI. That like seems like a human and like does the Parlor trick for us.
The Mechanical Turk?
Mechanical Turk stuff.
Right.
That can be popular, but not like long lasting.
Yeah.
Ultimately, it's a collaboration, I think, between these algorithms and human creators. I think it's a
Right.
creative effort that we see over and over and over again.
So the answer is no.
Which reveals something too. That says something as well.
Yeah,
but is everybody confident we will?
It's like, it's like saying, when is something going to be made by only one person? It's like nothing's made by one person, everything. I mean, some things are sort of made and shipped by one person, but it always takes a community to make it what it is. I just don't see AIs being in isolation without humans.
Okay, so
even if it's just if it was a learning system, like the learning system has to be presented with an environment. We talk about deep learning and machine learning. What's happening there is you take a certain computer thing and you expose it to a ton of data. Right, and over time, that data that it's exposed to becomes part of its system and part of the paintings it can make. So I just don't think these things exist in isolation. They're always existing with people. How the person decides to train them. I don't see a pure AI, right?
But there's a reductio ad absurdum to be made there that artists don't do art either alone because they are in context with their family and their community and their wars and their suffering and their economics.
And the art that came before.
Yes, exactly. So if we were willing to grant human artists the definition of, no, you are artist, you made one thing, you are the one person who made the thing, it extends that we should be able to at least say to some sort of autonomous system they get the same rights.
Touché.
And I usually come down bullishly on the idea that at some point within, 29. Let's assume I have that much left. Probably, hopefully, within my lifespan, we will get to see something that, when probed for its motivations, why did you make this thing? This non-human system replies back, no, it felt right. Leave me alone. I have to work on my paintings.
That's already what we have.
Right.
If you look at a deep learning
part.
painter, no, it's not volition. If you say, why deep learning painter did you put that splotch there?
We can expect its layers.
It's implicitly encoded.
Right. We can expect its layers. What I want is the volition piece. I want something that kind of goes like, now go, shoo. Leave me to my art. I want something that treats us. I want an autonomous system that treats us as pettily as an artist might treat us. And
that could be designed. The thing about volition.
It could be designed, sure.
No, the thing about volition.
I want it to emerge.
Let's talk for a little. I mean, I'm going to
You
just.
want an AI with an attitude.
You guys can start lining up for questions as they sort this out.
Take a
We're about to
second
go
in
to
your life
questions.
to do
Yeah.
that.
I want a
Go to the mic
snappy,
for
like
questions.
hipster trust fund AI to come out, like just give me my VR
Go ahead,
dad.
Stephen. Let
VR.
Stephen make his point.
Hold on, really quickly. I'm just going to resolve free will really quickly, and then we'll
You
get
can do
on
it
with
quickly.
it.
You can do it quickly.
If you want to talk about volition, I'm just going on a total branch here, limb rather. You have this deep learning system. It makes a certain painting. It decides to put like a purple splotch on something, right? And you say, why did you do it? And what makes a deep learning system deep is that we don't know. It's what's called an implicit model. If you have an explicit program, you wrote every line of code, you can see exactly, oh, this is the point of the code where it decides it, right? These implicit solutions, we don't exactly know. And why is that not free will? You're like, I don't know. It's in the system. It's somewhere in there. It's something. I can't determine it. Why could we not say that? Could we define that as the free will?
Close to what I want. I want an algorithm that was designed to do high frequency financial trading who says fuck this shit and then moves out and like moves into a studio in Brooklyn and makes
You
art.
want a
Like,
moody
that's
algorithm.
totally-
You want a
Yes.
moody algorithm.
Hold on.
I want that flavor of art.
You're talking about an entirely different thing,
Yes.
which is being able to go out into any context in the world, which is robotics. Like all the stuff I talked about in my first little spiel about how successful AI has been, like it's not actually going out in the world and dealing with sensors and the environment and what's in the sensor. And there's one point that I wanted to make in this talk, which I'm going to make now, which is what excites me about AI and AR. And there's a convergence of two things happening right now in the world. One thing is our ability with a camera to see the geometry in the room, to say, oh, these are things, that are shaped like a chair. And there's another piece of technology which can classify objects and say, oh, something shaped like that is a chair. Both these things right now are getting really good. And the thing that's going to transform the world will be a computer that can look and see what's in the world and identify what's in the world and know what it is because of all the depth sensing stuff that happens, like SLAM and depth sensing stuff, combined with all this like classification, I can recognize cats stuff. Those two things are going to come together. That's a huge piece that's needed to just send something out in the world and like move into a studio and rent an apartment and say, screw you, I'm going to Chelsea or whatever. So that's a huge piece, and we don't have that yet.
Yeah, the
comment, Kelsey?
situational intelligence, like knowing the context of a situation. If you walk into a convenience store and you see that there's a gun, there's a guy, there's cash.
Yeah.
They're probably
The
not buying
computer
guns.
doesn't know that it's a robbery.
I
We
just
know
think
it's a robbery.
It's data at this point, though. It's about having a system that can have so much data that they can then recognize that because it's in our data bank.
The learning context is hard to get.
But then the question is, where is this AI living? Because if it's living in a headset or something like that that's associated with us, then there's that relationship of the relevance to that AI that we are in the deli and there's a robbery going on. But will the AI find itself in the deli without us? If there's nobody there, does anybody here when the AI falls down in a forest? What is that saying? So it's like, is it
Right.
still all tied to the human experience? At what point does that kind of, point happen where it's just like, all right, see, humans, we're just running the planet by ourselves. That's not really the question.
That's a good question. That happens at the point that computers right now don't seek nourishment. Once you get computers...
For power, but yes.
No, they don't
Going to
seek
read a
power.
book.
Well,
Like
no,
there's
no, I mean,
experiments
like
with
electricity.
nourishment-seeking machines.
Let's go to the audience for some questions. You, sir, go ahead. Wait, at the mic. We got to get in line for the mic.
This is us being told we're having too much fun.
Right.
Yeah, there's no mic.
Is the mic just
no.
Just shout.
We can hear
activate
you.
the mic?
Yeah. Now it's on.
we
Okay,
go.
excellent.
Cool.
So great panel so far, guys. Thank you so much.
Thank you.
So as machine learning continues to kind of penetrate every industry the same way that the internet and smartphones have over the past few decades, Stephen, you've kind of already spoke to this, but do the three of you think it is more likely that AI, like a better than human AI, is going to be created directly or emerge?
Ladies first.
I'm going with emerge.
Emerge. It'd have to be emergent.
I'm going to say...
Even if we made it,
By
it'd
emerging,
be
do you mean,
emergent.
do you mean combining with human intelligence, or do you mean gradually evolving?
I mean, emerging out of the systems that we are creating, the same way that Uber, it wasn't one team of people who made all the elements that made the Uber, the same way.
You need the data set to train it in the first place.
I think it's going to be writing code that does it, rather than there's one team of scientists doing it's one thing.
Okay, on that narrow definition, I'll agree. I was going to say created, but I will agree now for merge if we allow emerge to also mean code that writes code. And I'll say that I'll go with created instead of emerge if we don't get to assume that, because for a lot of the costs of running and developing and the basic science R&D that's sophisticated to cobble that together, you'd want that kind of thing centralized, so it'd probably fall out of some corporate R&D lab. Because of how some API incompatibility or how round peg, square hole, a lot of communication channels could be, it would strike me as weird that it bootstraps itself together. And I'll throw another wrench in your question. The idea of greater than human intelligence is you're narrowly meaning to assume something conversationally like general intelligence. Can have this conversation, can ask that question. Because machines are already...
Not necessarily.
Machines are already wicked better at us than at a lot of stuff. They're beating doctors in differential diagnosis, detecting cancer cells in screens, finding oil in subterranean or underwater cavities, figuring out human motivation states. There's a lot that they're beating the pants off of us.
Yeah.
Those are specific intelligences, which gets back to the point of AI. What the heck counts as AI?
1945. I mean, my reaction to your question is you're thinking about it wrong, right? Computers have been smarter than humans. In the 40s, computing ballistics tables, it was that was the first application of machines, where it was shit, they can do things way faster, or even a century before that with certain analog computing tasks. So it's machines have always, for a long time, been more intelligent than humans in certain things. Maybe the question you're asking will be better than humans at everything that humans
General
can do.
intelligence.
Well, I think maybe more on the general intelligence side, and also I kind of define intelligence as the ability to predict. So what artificial, we all have our own definition of what that is, but the ability to predict, humans can do multiple layers of that in multiple ways.
In the 70s, lots of financial prediction software emerged that could beat humans in all kinds of ways.
Okay. Humans have predictions for
we have time for one more quick question. Just
Yeah.
keep us tight.
It's a good question, though, in theory.
Good questions, yeah.
I'd love to see the philosophical debate more, but I had a pragmatic question for Kelsey. Why is it important that you physically model these connections in a lab environment? Besides the power efficiency, I understand that's a huge advantage for consumer products, but actually modeling a brain, why is it important that you would physically map the connections, and they're limited physically in how close other connections are proximity-wise to be made, when you can model those in a virtual environment and not be limited in the same way our brains are when we form pattern recognizers?
Yeah, so I'm not a neuroscientist, so I'm not really trying to model the human brain, but my hardware is brain inspired. And so the whole motivation behind it is that modern day computers have two main drawbacks. One, the feature sizes are so small that we can't really make the switches hardly any smaller than they are. I think they're getting to be 4 nanometers.
That's the end of Moore's law.
That's
right
the
there.
end of Moore's
you're
law.
running into quantum shit.
We've been steadily making these connections smaller and smaller and packing them in denser and denser, so increasing processing speed. We're at the end of that. So we have to have a way to overcome that. And then there's the second thing that is a limitation on computers, and it's separating processing and memory. And this information transfer is a bottleneck in standard computers. So having a super dense interconnected network, you could potentially overcome both of those things. So you have a ton of connections, and you don't have to separate memory and processing. They're in the same thing. Maybe they're
does that flip the
compartmentalized
switch on
within.
new capabilities in computing that we haven't seen before? I mean, does that enable things we can't imagine now for computers?
Yeah, we
to do?
can't imagine that. It's all the major companies are researching this sort of system. Yeah.
Fantastic. I learn every time I hear you guys explore these ideas. Quickly, Boo, where can people find more about your work in the mill?
Themill.com. That's probably a really good place to start.
Perfect. Do you have a personal place to check out?
You can definitely find me through there. That's
Through there.
the
Okay, that's the
easiest
best
way
place.
to say it, yeah.
And Kelsey?
You can find me on LinkedIn, and you can look up my lab's website, but it's, I think, on my LinkedIn, so.
Awesome. Ramsey?
You can find me and my company's work at boundless.ai, and you can find me on Twitter at RAB1138.
Steven?
Yeah, you can find out about my company, thevaincompany.com. I also encourage you, my Twitter handle is Scully, my last name. It's a pretty rare one, so you can search me. But if you're curious about the more philosophical shit, I'm writing this series for Medium right now called Proof of Machine Consciousness, where I explore all the things that people think consciousness means from a computer science perspective. And I'm becoming more and more convinced through this series that a lot of the things we don't ascribe to machines, they kind of do and have done for a while. It's a curious series, but I like to pontificate.
Fascinating.
Find some stuff online.
You should all listen to Stephen when he pontificates. It's quite good.
It's awesome. And my show is at mindandmachine.io. Thank you guys so much. This has been awesome.
Thank you.